Now, in a previous video, we've introduced the idea of what a logarithm is. Now, throughout the higher course, working with exponentials and logarithms are going to be two of the key things we have to be able to do. Well, let's focus on logarithms for a little bit, because one of the key things we have to be able to do is solve equations that involve these. Now, in order to be able to do that, what we have to be able to do is work with logarithms and know the 5 key rules and laws of logarithms that allow us to manipulate them, work with them, and ultimately solve these equations that they're going to be part of. And that's what this video is going to focus on. Now, as I mentioned, there are 5 key rules and 5 key laws, and here they are. The first law is if you've got log to the base a of x plus log to the base a of y, you can combine them and say that that's equal to log to the base a of x times y. Now, there is a key thing I need to point out to you here. It's log to the base a of x and log to the base a of y. They both have to have the same base value. If it's not, so if it's log to the base a of x plus log to the base b of y, and they are two different base values, you cannot combine them. Do not fall into that trap. The second rule says if we've got log to the base a of x, take away log to the base a of y, that gives us log to the base a of x divided by y. So if we're subtracting them from each other, it becomes a division. If we're adding them, it becomes a multiplication. And the key thing to look at is the second one. So where it says minus your log to the base a of y or plus your log to the base a of y, that's the second term involved here. So for multiplication, it's not too bad because they're both multiplied, but for division, you especially have to pay attention to this, because the second logarithm, the one that is being subtracted, that gives us what goes on the bottom of our fraction when we're doing it. Third key rule we have to be able to work with, log to the base a of x to a power. So let's say log to the base a of x squared. What we're able to do is bring the power down to the front of the logarithm and write it as n times log to the base a of x. So we're able to jump that power down to in front of the logarithm and just make it a coefficient. Another key thing that we have to be able to do is remember that if we have log to the base a of 1, so log to any base of the number 1 is always 0. Every single time. It doesn't matter what your base value is. It is always 0 if you take log of 1. And if you take log to the base a of a, so you're using the base power in there, that will always give you 1, because essentially it's asking you, what power of a gives you a? Well, the thing that gives you itself is 1. Any number to the power of 1 gives you that number itself. So you have to bear that in mind. And again, the same rule applied that we said before. Anything combining in these logs, so your base power or your power numbers within them, are always bigger than 0. So these are the 5 main rules and laws of logarithms. Let's have a look and see how we work with them and what we can do with them. Let's imagine we've got log to the base 5 of 2 plus log to the base 5 of 4, and I want to evaluate it and combine it. First thing to check is the base powers. That's a 5, that's a 5, great, I can combine them. Same base power, so I know I can do it. So it's going to be a single logarithm to the base 5. Now it's a plus, so it's going to be this number here times this number here. So it's going to be log to the base 5 of 2 times 4, which in this case is going to give me log to the base 5 of 8. Sorted. Now at this point, if I could simplify it, I could keep going, but I can just leave it like that. Second example here, log to the base 4 of 6, take away log to the base 4 of 3. Again, same base power in both of them, so we're able to combine them. Now remember, subtract means a division, and it means it's the second one that is the bottom of the fraction. So in this case, it's going to be log to the base 4 of 6 divided by 3. Now in this case, that is log to the base 4 of 2. 6 divided by 3 is 2. And here's a cheeky wee thing for you. I know that that's going to be equal to a half. How do I know that, you ask? Well, remember, this is saying what power of 4 gives me 2. So 4 to what power equals 2? Well, remember, 2 is the square root of 4. And the square root of a number is the same as saying it's to the power of a half. So 4 to the power of a half is 2, so my answer to that is going to be a half. If we're able to think like this, we can actually work quite well with logarithms. Imagine I want to take a third example that says 2 times log to the base 7 of 3 and express it in the form log to the base 7 of a, so a singular number. Well, this is going to jump to our third law. So our third one, which was n times log to the base a of x equals log to the base a of x to the n, the one with the power. So we could bring the power down or we could take the number up as a power. So in this case, I'm going to take the number up as a power and write it as log to the base 7 of 3 squared. And then it's just a case of evaluating it. And we get log to the base 7 of 9. 3 squared is equal to 9. Job done. Again, I can't simplify it anymore beyond this point. I'll just leave it as it is. Our last one here is evaluate log to the base 7 of 7 plus log to the base 3 of 3. Now, first thing to look at is the bases. There's a 7 and there's a 3. We cannot combine them using our laws. So we can't combine them using the first rule, which says that 7 times 3, because of the different base values. That's going to be a little bit frustrating. But if you notice, both of these fall into the category of log to the base a of a. A 7 is a base here and a 7 there, a 3 is a base here and a 3 there, and that equals 1 every single time. So actually it's quite straightforward because we know that this is going to be equal to 1, and this is going to be equal to 1. So it's the same as saying 1 plus 1, which is 2. Great, we can work with each of these rules on their own. That's fine, that's easy. What about if we're combining them? How do we think about those sorts of questions? Well, let's have a look. Imagine I want to evaluate log to the base 12 of 10 plus log to the base 12 of 6, take away log to the base 12 of 5. Again, the first thing you should always check is the base values. Now, the base value in every single one of these logarithms is 12, so I can combine them. And then it's a case of thinking about your rules. Now, remember, if you're adding two logarithms, it's a product, they multiply. If you're subtracting, it's a quotient, so it's a division. So in this case, we're going to add the first two, which means that we're going to multiply these two, and that is then subtracting this logarithm, which means it's going to become a divide. So in this case, I'm going to have log to the base 12, and I'm going to have the first two here are multiplying together, so it's going to be a product there, but then it's going to be divided by the third one because it's a subtract. So in this case, I'm going to end up with log to the base 12 of 10 times 6, which is 60, divided by 5. And we simplify it as much as we can at this point. So 60 divided by 5 gives me log to the base 12 of 12. Well, look, base number and the number here are the same. Ultimately, we know that's going to equal 1. So simplifying it down when it's more than one term is actually quite straightforward. We just have to make sure of these little tricks. Again, one of the key ones, same base number. However, when we've got coefficients, that can add an extra level to it as well. So imagine I've got log to the base 6 of 4 plus 2 log to the base 6 of 3. Both logs have the same base. Great, we can combine them. But the coefficient here presents us with a problem. Now, when we are doing one of these questions, there are two ways we can go about it. We can either have both of them in the form log to the base a of a number and combine them that way, or something times log to the base a of a number, where the number in front, the coefficient of both, is the same. Now I'm going to show you how to do it both ways, and you can think about which one actually seems the most straightforward too. So let's imagine I'm going to do this method first. So I'm going to combine them both so they're both just a number within the logarithm. So my first one, log to the base 6 of 4, stays the same. This one here is coefficient in front, so I could take up and it becomes the power. Becomes log to the base 6 of 3 squared. So in this case, that gives me log to the base 6 of 4 plus log to the base 6 of 9. And then I combine them there at that point. And because we're adding, it's a product. So it gives me log to the base 6 of 4 times 9. Log to the base 6, so 4 times 9, 4 nines are 36. Gives me 36. Now I want to simplify this as much as I can. Well, 6 squared gives me 36. I can write that then as log to the base 6 of 6 squared, because here's a cheeky thing for you. If we have log to the base a of a to the power of n, I can use my third rule of logarithms to bring it down and write it as n times log to the base a of a. And I know log to the base a of a is equal to 1, so that just gives me n. So I can actually use that on this one to simplify it even further and write that as 2 times log to the base 6 of 6, which I know log to the base 6 of 6 is 1, is going to be equal to 2. So it's going to give me that one quite simply. Well, I said to you there's another way we could do it with the coefficients, so I'm going to show you that one as well. So I want to write them both with a coefficient in front that's the same. Well, this one has a 2, so I want to write this one in terms of that as well. Well, I know log to the base 6 of 4 equals log to the base 6 of 2 squared, and I can then bring that down to the front and write that as 2 times log to the base 6 of 2. If I rewrite it like this, they've both got a coefficient of 2 and I can simplify them that way. So let's do it. So I can then rewrite that as 2 times log to the base 6 of 2 plus 2 times log to the base 6 of 3. If I take the 2 out as a common factor, that then becomes 2 times bracket log to the base 6 of 2 plus log to the base 6 of 3. And I can then use my addition rule to get these two together with a product. So that then becomes 2 times log to the base 6 of 2 times 3, which is the equivalent of 2 times log to the base 6 of 6. Same answer as this. Log to the base 6 of 6 is 1. That just gives me an answer 2. So there's two different techniques for solving that one type of problem. Pick whichever one is easiest for you and whichever one clicks with your brain a bit better. So if you prefer working with the first one, where you get them both in the same form without coefficients in front and the same base and combine them, that's fine. Go for it. If you prefer to have them both with the same coefficient and treat it like a common factor, go for it. The bottom line is you have to be able to work with all of these rules, you have to be able to recall all of these rules, and you have to be able to use them to manipulate a logarithmic function to enable you to solve it.